Hello friends, once again welcome to my channel. I hope you have gone through the last videos and did the exciting practicals. We have implemented Spring AI with AWS Bedrock using its LLMs. We also implemented RAG using knowledge bases, set up Code Llama for local validations. So in today's session, we'll see how we can implement RAG using Spring AI. So let's take an example, okay, where there's a classroom, there's a professor, student, and the student has some textbooks for reference. So let's go to the student first, okay. The student is having some knowledge based on his subject, and that knowledge is say outdated or it's incomplete, okay. For example, consider that student has Java knowledge, but he has Java 7 knowledge, okay. That's outdated. And he needs to he has reference to Java 8, Java 11, all the LTS versions. Okay, just an example. So the professor asks the student, for example, what is stream in Java? Now the student is not aware, okay, because his knowledge is updated and is not and incomplete. So what he does is he'll refer to some online source or to some textbook to see what is the stream API. He will find search for the answer and he will give the answer back to the professor. So here the student is specifically referencing some external sources like internet, through Google, or through textbook, or say phone a friend. Okay, so he refers to the sources and gives back the answer to the professor. So I hope you all have got what is RAG, okay, and what the process is. So let's understand what happens internally when we implement it in a real time. So same, we have a user. The user will query to the bot. Okay, we have a say we have a chat bot. Okay, Chat GPT or Google Gemini or say uh, Olama. Okay, Code Llama. We query to the chat bot. Okay, so the chatbot. Okay, we query using a natural language, say in a native language or in English or say any other language. We call it as natural language. Okay, and that query or that prompt is splitted into small chunks of data. Now, those small chunks is consumed by the embedding model. Okay, so this is the embedding model. So the role of the embedding model is to convert text to vector. Now here vector comes into picture because we don't want to search based on the exact string. Okay, we want to search based on the we have to do a semantic search. Okay, means based on the chunks. We need to query based on the chunks or based on the partitions of the data and not the exact string. So the most likely answer will be returned to you. So the embedding model is responsible to convert the text to vector. That vector information is stored in the vector-db. Okay, so say when our applications load, we'll store some information into the vector-db. Say we have a PDF, say company policies. We have a PDF. The PDF will be stored into a vector-db. Okay, now why vector-db? Because vector-db handles storing of embedded data, that is data which are converted into numerical format in multidimensional. Okay, now Since it is a database, we need some application for it, some application to host that or to access that vector DB. So in our case, we'll go with the PG vector. If you are using AWS, I think you all can go with OpenSearch serverless. You all can use that. Okay, it allows you to create collections for vector database. So embedding model will convert the text to vector. Based on those vector conversions, we will query in the vector DB. So what is stream API? It will be converted to some vector embeddings. I mean, some numerical representations will be generated. Those numerical representations, based on those numerical representations, will search in the vector DB. Okay, and then the cursor further points to the LLM model. Okay, where it will take the answer what is generated, that is the context and the prompt. It will package these two things and it will return the final answer back to the user in the natural language. So this is what happens behind the scene. So we have the main components in this flow is the embedding model, which will convert the text to vector. The PG vector where the actual vector data is being stored. So embedding model will do the semantic search. Based on the most likely vectors, it will fetch the data. That data is sent back to the LLM, and the LLM responsibility is to send back the final answer based on its natural language. Because if we send back the vector answer, we'll not understand it. We'll think that the model is not working properly. So we'll send back the final answer through the LLM in its natural language back to the user. So without wasting much time, let's hop on to the practicals where we'll implement using Llama and Spring Boot. We'll need few prerequisites, okay, before starting up with the actual coding. So we'll need a chat client, a chat model. So since I'm using Llama, I'll be using model Llama 3. So earlier I was using Code Llama. We'll need an embedding model and a Postgres data source. Okay, so to get running Code Llama, you can refer my previous videos. Okay, if you see in the playlist, I have the Spring Boot AI tutorials where I've shown how we can integrate Spring Boot AI with Llama. So follow the entire process as it is. Okay, but instead of Code Llama, we'll go with Llama 3. Okay, so where earlier I run Olama run Code Llama, here we run Olama run Llama 3. Okay, so if we run this, um, it will take some time and your local server will start up. Okay, next we need an embedding model. So I'm using Nomic embedded text. There are many embedding models. You all can go through them and decide which one to, if you all want to select some different one, you all can use it. But I've gone with Nomic embed text. So this is the command which is given, Olama port Nomic embed text. So I've executed that command already and it has downloaded the files, okay, the binaries for it. Now, so this is now with this you have the basic setup ready. Okay, now coming to the vector part. Okay, I need Postgres SQL and a vector DB. Okay, so uh, okay, so what we can do is I've installed pgadmin Postgres locally, but getting vector inside it is a tedious task. I need to download the binaries and then try to get it in the pgadmin. It's very hectic. Okay, so a quick way what we can do is we can use the one which is provided by Docker. So Docker, there's a Docker container running. Okay, for pgvector-db, which gives the support for vector database also. Okay, vector embeddings. So what you'll need to do is just run this Docker run command. I'll provide this command in the description. So once you'll run the Docker command, it will run the Postgres vector container on your Docker locally on port 5433. Okay, now I've changed the port here because it was clashing with the Postgres port. So that's one setup you'll need. And once you get pg admin, okay, you can give a connection name, a general name to identify the data source. So as you see, I've given pg vector-docker. Okay, you go to connections. Next, give the host name. Host name will be localhost. Okay, localhost on port 5433. Postgres. Okay, and if I do save, okay, one sec. Password. Is my Postgres running? Docker ps. Yes, it is running. Postgres 5432. Okay, sorry. It was password was down. My bad. Okay, it created a PG vector 2. Okay, but since I already have okay, I'll remove the server. Okay, since I already have this. Okay, now we need the vector extension. Okay, so we just run this. I think it already exists. Okay, so I've already exist the vector extension is already existing there. I need a vector stored table with some ID, content, metadata, and embedding. Okay, so embedding where the data with the numerical form of the data will be stored. So let me execute this query. Not sure. Yeah, okay, query execute. Select start from vector store. Okay, so presently it's empty. Okay, now okay, fine. So we'll go to the Spring part. Okay, now we'll use through Spring Initializer. You all can download the Spring project. Okay, so what we obviously we'll need web if we want to access through REST controllers. Okay, we need Olama support and we'll need PG vector. That's it. These three dependencies and you all are done. Okay, generate. It will download, extract it in your favorite ID. Okay, now this is the application.yaml properties what we'll need. So again, this properties are already there in this video. Okay, just few extra things what I've added. In there I've provided till chat model also, but we'll need to provide an embedding model. Okay, nomic embed text. Okay, so nomic embed text. You just take this name and paste it over here, and vector store pg vector initialize schema true. Okay, we'll need this and the data source connection. Obviously, we if you use SQL or anything Oracle, we provide a connection string, right? So that's what we are providing over here, connection string, and we are telling AI to refer to the vector store. Okay, so now let's start with the bin initializations, creating the controllers, creating the config files. Okay, so we'll go with rack config first. Okay, so in order to give the prompt, okay, first we'll create a controller. Okay, uh, we'll create a rag controller. Okay, and it is at the rate rest controller. Okay, okay, and we'll need to add a service in it. Okay, so we'll need uh, private final rag service. Okay, and do constructor initialization. Okay, one more thing, guys. I'm using HTS. I'm trying to check for IntelliJ, but I'm not getting any free version. It's everything is trial. So if you all have any idea where I can get the free version, please do drop a comment. Rack service, this dot rack service. Okay, this is fine. This will give an error because we don't have the rack service for now. So let's create a rack service. Class rack service. Okay, so finish at the rate service. Okay, so we ended at the rate service. So okay, now errors from here are gone. Okay, I'll close this. Now go to rack service. Now rack service, what we need? Private. We need vector store. Vector store is provided by Spring AI Vector. Okay, and private final. We need a chat client. Okay, now vector store. Okay, sorry, vector store. Okay, initialize using this rack service. So public rack service. Okay, uh, vector store chat client. Okay, this dot vector store is equals to vector store. This dot chat client is equals to chat client. Okay, but chat client will be provided by builder. Okay, so we need chat client, not chat client dot builder. Okay, so chat client builder and chat client builder dot build. Okay, so this way we can initialize chat client and vector store. Okay, we'll create the beans for those as well. Okay, because since we are constructor injectioning, we'll need the beans, right? Okay, now one method. Uh, okay, so let's shift to the um, part where we need to load the data. But before loading that, we'll what we can do is uh, we need to instantiate these objects. Okay, so first we'll go to configurations. Sorry. We'll create a class, new class as rack config. Okay, rack config. We can go with at the rate configuration and we'll create a bean of chat client. Okay, so public chat client, chat client. Okay, and same we'll need chat client dot builder return builder dot build. Okay, we have the chat client ready. Okay, now this chat client will be used in the rack service. Okay, fine. Now what we need is the ingestion service. Okay, now ingestion is a fundamental step of rack where the data is loaded into the vector-db. Okay, so let's go and create the ingestion service. New class ingestion service. Okay, fine. Okay, we'll mark this as at the rate service. Okay, now here we need a rack store. or basically you can say PG vector store. Okay, so uh, private final PG vector store. Okay, so PG vector again provided by Spring AI. Okay, we got the vector store. Okay, again public ingestion service. Okay, we'll initialize this. Okay, and this dot vector store is equals to vector, oops, vector store. Okay, now we have initialized the vector store. Now we need to load the data, the document into the vector-db. Okay, so I've created this in source main resource docs info.txt. Just any content, like you can put, I just add some content, spring boot drag and pg vector. Okay, so just a small content. It's a completely unstructured data, raw data. Okay, so uh, let's create a method like ingest. Okay, something related to ingestion means adding, inserting to the vector db. Okay, so public void ingest text. Okay, now what we'll do here is we'll get the contents of the file first. So string contents is equals to, we'll use the files dot read as read sorry, read string. Okay, and we need to give the path. Okay, so path dot off. Okay, off. Okay, so I need to give the path. So source main resources. Okay, slash info.txt. Okay, now what is there? Okay, throws. Okay, so okay, it will, since it's a part of IO, it will throw an IO exception. Okay, fine. Now I have this, I have the contents of the file. Now this contents of the file, I need to create chunks of it. Okay, so how I can create chunks of it? I need to split the contents. Okay, so we can use text splitter. Okay, if you are using PDF, then you all can use, I think we have PDF, some PS, there are some class. Okay, that's a different dependency what we have. So you can have PDF splitter as well. Okay, so I'll put a video on that as well. Okay, so text splitter. Okay, we can use splitter is equals to. Okay, now every everything is tokenized in this. Okay, so whatever your chunk is getting created, whatever your chunk you're going to process it and put it into the vector db. Okay, everything will be tokenized. Okay, so we go to new token splitter. Okay, now uh, what we'll need to do, we'll need to get the document out of it. Okay, so list of document, list of document. Okay, and this will nothing but chunks is equals to splitter dot split. Okay, and what we need, new document and string contents. Okay, so we have got the chunks. Okay, so we have splitted the text and we have got the chunks. Now these chunks we'll need to add it into the vector store. So vector store dot add. Okay, add a list of document which is chunks. Okay, and maybe one system dot out dot print, okay, to confirm like the rack data loaded. Okay, so rack data loaded into pg vector. Okay, yeah, so we have a ingestion service. Now we need to get this when the application runs. Okay, but before that we need all the bins to be initialized. So what we can do is we can uh, maybe when the application is ready, right, we can have this performed at that time. So application ready is an event. Okay, so event can be accessed using event listener, and in that event listener we'll provide what kind of event we need. So application ready event dot class. Okay, so when my application is ready, it will load it, it will run this and enter to inside the pg vector store. Okay, so I have the pg vector store ready. I need to go to rack service. Okay, now uh, okay, so pg vector store is ready. Pg vector store will load it into the rack. Okay, now let's go to rack service. Yeah, so I'm already on rack service. Okay, in rack service, what we'll do is we'll create a method which will take the prompt and which will search in the uh, vector store. Okay, now, okay, uh, so if you remember, we created a class with not class, sorry, we created this table with vector underscore store. Okay, so if we go to ingestion service and if you go to pg vector store, okay, so if you see the default table name they have mentioned is vector underscore store. So what it will do, it will create, it will refer the default table vector underscore store. Okay, you all can uh, create your own table, but for practice I'll be using with the existing default vector store. Okay, so you can get the table name from the uh, pg vector store class itself. So let's go to, yeah, we were on rack service. Okay, now we'll create a method public string ask. Okay, we need to ask to the rack, okay, some question. Okay, now earlier what we did chat client, okay, dot user dot prompt dot user dot call. Okay, now before that we need to get the data, okay, and data from the rack, from the, sorry, from the pg vector db, but that will be a similarity search, not an exact query search, not a select star from exactly as it is. No, it will, whatever the embeddings are stored in the pg vector, based on that it will search the relevant data. Okay, so here we have the vector store, so we can use vector store dot we are using similarity search. Okay, similarity search, and instead of directly passing the query, okay, we can go with search request. So the search request will need search builder, search builder. Okay, search request dot builder. Okay, dot. Okay, now this will take the query. Query is nothing but the question, and dot build. Okay, now this wants the list of documents. So list of documents. Okay, so I can put it docs. Okay, generated util and document provided by Spring AI document. Okay, so if you go to ingestion service, we split it into the list of document, that is the chunks, and that chunks we are adding in the vector store. Okay, now same thing for retrieval. What we'll do, uh, we'll do a similarity search on the vector store and store it in the form of list of documents. Okay, now we need the content from this document, right? So what you can do, string content, okay, equals to, now we have this docs dot will stream into, okay, since it's a list, okay, we'll need to go through the contents in it, we'll stream over it, okay, and map the formatted content. Okay, so we'll do map, okay, and document method referencing formatted content. Okay, but since it's method referencing, we'll remove get formatted content. Okay, sorry, get format method name, get formatted content dot collect. Okay, and we need to join the strings. Okay, we need to merge everything. So collectors dot joining. Okay, and we need to put a sequence, a joining sequence. Okay, so slash n. Okay, now what's the error? Okay, error is gone. Fine. Now we have the content. Okay, rather I can name it as context. Okay, now we'll create the okay, so now here we can easily return chat client dot prompt, okay, dot user. Now user will require a prompt, okay, okay, so some prompt dot call, okay, okay, but where is the prompt where we are telling the model to refer it from the document? So again, what we can do is we can create a string prompt, which is, and we can give some, okay, we can give some prompts to it. A prompt means we can tell the model like what you need to do. Okay, so answer based only on the context below. Okay, where we'll tell, okay, context is something what will be and some question. Okay, dot formatted. Okay, formatted. Now we need to pass what, context comma question. Okay, now this is ready. Okay, so what we are telling the prompt is answer based on the context below, and we need to pass the context and the question, because we're also telling, okay, refer to that question, and based on the question refer to the context. Okay, so now we can return chat client dot prompt dot user. In user we'll pass the prompt, okay, dot call dot content. So we'll get the content, it will be returning from the service, and once again we go to the controller, it will be returned from the controller. Okay, now okay, here in the controller layer uh, we need to add some mapping, right? So let's add a post mapping slash ask. Okay, okay, sorry. Okay, and public string ask rag, ask to rag. Okay, and at the rate request parameter. Okay, so we'll take say query and we'll assign it to string question. Okay, and what we can do, rag service dot ask the question. Okay, and we can return this because it is anyways a string. Yeah, so make sure you have the LM and everything ready, all the setup is done. Okay, now let's run and see this. Let's see if we get any issues. Well and good, we'll try to solve them. If we don't, still well and good. So my application has started. Okay, so let me skip the breakpoint. Okay, some shutdown has happened. So info dot so okay, source main resource info dot txt. Okay. So ingestion service source main resources slash docs. Okay, I forgot docs. Okay, let's debug it. All. Initializing PG vector store. Okay, everything is here. Tomcat starter. Okay, I don't see any errors. Okay, now we started the service. So on event listener application ready. Uh, this thing has processed. So let's see whether we are able to see this. Okay, so we can see this over here. Rag data loaded into PG vector. Now if we go to our table, select star from vector store. If we run this, oh great, we have some entry over here. So some unique ID, the content, okay, the overall content of the text file. This is the metadata, and this is the embedding vector. Okay, I'll I'll take it into Notepad. So you see all the data that we entered from the text file is converted into this vector annotation in numerical format. So every time what we do, we give a query, it will convert it into this format, and based on this values and based on what uh, it has been passed from the prompt, it will do a similarity search and get it for us. Okay, so let's go and create a request. It's a post mapping, right? Yeah, and my endpoint is post mapping slash ask. So http colon double slash localhost 8080 slash ask and parameter. So passing query, and let me open the text file. What does rag stands for? Okay, or what is pg vector? What is pg vector? Okay, send. Okay, yeah, it takes some time, so we'll wait till the response is loaded. Okay, once again, make sure that you have the uh, your llama local setup running. Okay, you have executed the Docker command to generate get the container which will support vector embedding, and you also have the nomic embed text embedding model ready in your system. Okay, so you see we have got the response. PG vector enables vector similarity search in Postgres. So enables vector similarity search in Postgres. So exact it is given, and it has added something of its own based on the content. Okay, so you can handle that in the if you go to service and you can ask her do not print based on this context. So whatever you tell the model, it will listen to you. So that's the beauty, right? So you tell the model whatever you want to print before the response, it will take that, it will take the context, it will take the prompt, okay, and it will combine everything and it will give you the response. So this is the end-to-end implementation of for RAG. You all can use PDF, you all can use text, you all can use image, you all can use any type of data you want. But for a quick start and quick learning, you all can use Llama local setup and just do a small practical using text file. Once you gain confidence, you all can try with PDF or some other type of input data. So yes, please do like, share, and subscribe for more such contents. Thank you. Thanks for watching. If you have any questions or if you are stuck anywhere, please free to feel free to comment. Thank you.